Good afternoon and welcome to the NMOP session. We have Reshad here and I'm Benoit, so welcome again. We have two sessions for NMOP. This is actually the first one. The second one is on Wednesday. So the Notewell, it's not a new Notewell, it's a new formatted slide for the Notewell. So this is actually what you accepted whenever you registered the IETF, that everything that you say is a contribution. And if you are aware of any IPR, you should declare it. There are a couple of references on that slide. You should be aware of this whenever you sign it. And note really well that this is a professional environment and we ask you to treat each other in a personal way, which was always the case in NMOP, so thank you for that. If it's not the case, there is a procedure there that you could follow. So a couple of tips. So first of all, we've got Thomas who's going to take the notes. Thank you again. If you could put the meeting minutes link in the chat, it would be great. This is a collective effort. So feel free to go online directly if what you mentioned was not clear or, for example, if the name is not there, whatever, help with the meeting minutes. So for the in-person participant, make sure you sign into the data tracker. That's a way to use the session and also to join the mic queue. There is a small hand there, and that's a way to that's a way to participate. Are we good? Okay. You can download either the Meetecho Lite or the full client, but the key point is that make sure your audio is off. I don't believe we have any remote participants, so we're good on that front. If you have questions, anyway, feel free to use a headset, and it's recommended just for a quality point of view. This is the agenda of the first session today. Historically, we've been having two sessions, with the second session being operators sharing their incidents, but also the hackathon results. And that's something we're kind of proud of, that we have hackathon development at the same time as the specification. Now, it's always a challenge to try to keep this guideline of having the hackathon results in the second part. So we made an exception to that rule because sometimes it's just easier. For example, whenever we're going to present the message broker integration, all the drafts, we thought it would be easier to have the hackathon result just after that because we relate to the same set of drafts. So we broke the rule of having session 1, session 2. The thing is that both sessions are full. So there is protocol, there is hackathon, there is share your incident. Now let me go through the agenda to see if there is any agenda bashing. So we'll start the Yang push to message broker integration. Then, as I said, next to that by Yannick, the implementation, the hackathon result of the previous session. Chin will present the Yang data model for network incident management. We'll go to the CMAP. Then the RFC 3545 20 years later, which by the way, I didn't call 3545 bis, right? Then we'll go back to the Yang message key for, we'll go to the Yang message key for message broker integration, which is an individual draft. And from that on, these are all individual draft. The next one being AI-based network management agent. Then the model for distributed authorization policy sharing. Then Nigel will present on generalized capability principle, and we'll finish this with a graph-based meta schema. Now, whenever we schedule this, it's always like a strong exercise to how much time do we allocate and what is the right order. So this is the thinking, this is our thinking. First of all, working group documents. We're here to solve the problems from the charter. Second of all, we go to the individual drafts. Now, it's always an issue for us if you have a brand new IETF draft and it's not even discussed on the mailing list. So somehow we conclude it should be lower in the priority list and we should allocate less time. So it's also your role to make sure that if you draft that they are discussed on the mailing list. What else? Document status. So if we start from the bottom, we've got the terminology in the RFC editor queue. Now we've got the CMAP concept that should go, depending on the feedback of the room, to workgroup last call after this IETF. We adopted since last time the RFC 3535 20 years later. Something that we want to highlight, this is the red circle, is that 2 documents have not been updated since May, which means before the previous IETF. While, and I believe it's in the next slide, that we have the milestone and they should arrive pretty soon, like December. So that's an open question to the authors. I hope it's going to be addressed today. So reviewing the milestones, the next one is the CMAP concept. Digital map is still the old name, right? Digital map is CMAP, concept, requirement, and use cases. And yes, I see Thomas in the queue and okay, please go ahead.
Just on behalf of the anomaly detection authors, so we already have some updates on the documents, but we did not make the timeline. So you can expect probably somewhere mid of November, 3rd week of November, that we're gonna submit draft updates.
Very good. Thank you. Interim meetings. I think for the first time we have no interim meetings, and that's something we've been having. So feel free to drop us an email if you want to have an interim meeting, if you want to finalize the document on the existing or projects from the charter. There is also a knowledge graph design team under Reshad's supervision, and we will receive an update to Wednesday with what should the IETF do in terms of knowledge graph. And there are no liaison statements that we know of. So, Reshad, anything to add?
Thanks, Benoit. So one thing I'd like to add, which I think I mentioned at last IETF, sorry for being a broken record, is we need the working group to review documents. You know, for example, at adoption, you know, often people say show of hands, interesting. We've got a couple of documents which are going to start working group last call soon. And if it's, you know, Benoit, an author of the document, and me as main reviewer, that doesn't pass the bar for me. I've seen that problem in other working groups where I've hesitated to declare working group last call. So those documents are a product of the working group. You're part of the working group. Now, I understand that you cannot review all docs. We're all busy. We've got day jobs. But, you know, you can pick one if you're an author. Something I've mentioned to people, find a friend to review your doc and you review their doc, as an example. But we need document reviews, otherwise nothing will be produced, or it's going to be produced at a much slower rate than anticipated. Thank you.
To the point. All right, so now we go with the first session.
Thanks, Thomas.
This is, yes, Thomas.
Okay, hold on a second. Just bear with me. Yes, right?
Okay. So on behalf of the authors, I will be presenting updates on 2 documents. One is on the message broker integration and the other one is on the telemetry message. So on the message broker integration, we had a couple of updates. Mainly, we got a review from Paul Atkin. Many thanks. And we addressed all of his comments except of one. He raised a point on Yang and data mesh industry adoption claims, which we are claiming in the document. And he was pointing out when we have such claims, there should be a reference to a document where this is clearly written. And we did quite some searching, and we came up with two research papers which are describing the adoption of Yang and also the data mesh implementations. I put them on the slides, and we would like to add them as references in the next document update. And we would like to hear from the working group whether this works, or if not, whether you have better proposals, better references we could add on the document. Then other changes in the message broker integration document was and you will see in a later presentation when we go into message key, we're describing also the relevance of a stream catalog. But the stream catalog was just mentioned in the document in the terminology section. So we added also a description what a stream catalog actually is, and also in the overview diagram, I marked it in red, we added there as well. I like to remind that at IETF 123, we had an input from Nacho, whether stream catalog is the right term, whether we should use data catalog. We authors believe that stream catalog is more widely used in context of a message broker. However, if the working group has a different opinion, we like to have a good conversation on this. Then in the notif envelope document of Yang push, we had some reviews with the Yang doctors, and there there is in NetMod there is RFC 6991 bis, where some new type def in terms of the host name are being defined, and therefore we were updating the leaf name but also the type def information. And now in this document, when we are describing that relationship, we are now inheriting that change. And last but not least, regarding message broker reference implementations, we were referring in the past to Apache Kafka and RabbitMQ. And we saw, especially when we're now going to the telemetry message key, that probably it's better to reference Apache Pulsar instead of RabbitMQ, because most of the concepts on partitioning, topics, message keying, topic compactions, and so on, both Apache Pulsar and Apache Kafka are supporting all those different mechanisms. So therefore, it's probably better to reference Apache Pulsar instead of RabbitMQ. Now, going into the next steps, and the chairs were pointing out before also nicely on the milestones. So the submit architecture for Yang push the message broker integration to ISG. The aim on the charter is September 2025. We have now November. So give an overview. So we have now several iterations. We have multiple implementations, and the last remaining normative document reference, which did not pass working group last call, is the notification versioning. And today morning we had the NetConf session. So we requested their working group last call. And the second one is the message broker telemetry message, which we have now in the next slide. And there the intent is for the telebroker message to go working group last call by the next IETF, so in March next year. So in order to move forward with the message broker integration, we suggest to have an early ops directorate review. So just to make sure we covered everything from an operations and management perspective. And then maybe since the document is stable, we have implementations going then to working group last call.
So just want to make sure I understood. So you want working group last call after the working group last call of the document in NetConf?
I think here, I think the decision is to the chairs, to the community here. I think just I wanted to know this is the last remaining really normative reference. I would wait for the moment on the decision on the NetConf chairs, like whether they are accepting the request and going to working group last call, and either in parallel or after that working group last call has concluded, I would follow up with the message broker.
Okay, yeah, I think because intuitively my preference was to wait for the working group last call, not to start, but to close.
Sure.
Okay, NetConf, so if you're okay with that.
Absolutely.
Okay.
Yes. We just think that basically I would not wait for the telemetry message. I would first start with the message broker integration and then follow up later shortly after with the telemetry message, because the telemetry message depends on the message broker integration. We will see also there is a normative reference. So they are, and also the two documents are related to each other. So it's good to have that more or less in a similar time frame.
Okay, so
I see Mahesh.
One quick one. Can you go, because it's maybe related to what Mahesh is going to say, can you go to slide 11?
Sure.
Because we discussed that, and this is the backup slide that was not supposed to be presented, but in there we kind of listed because you requested an Ops Directorate review, now there are multiple references. And I asked Thomas to do this because maybe you could be finding Ops Directorate members who've been reviewing the references so that they know already about the topic and not have a new Ops Directorate members. You have to review all of the references in order to understand what we're doing here.
Exactly. So I put the document names, the state, and the reviews and the names of the reviewers on 11 and on slide 12.
Okay, that should be helpful, but that's not what I came up for.
Good.
To the first slide, I think where you're talking about Paul's request to add a reference.
Okay, let me go back. Yeah.
My only question is, how stable is that reference?
So these are references to two research papers.
Okay, so they are stable references.
Yes.
They won't disappear by the time that.
So so actually from the Yang adoption claims, there was actually an IETF blog post from Benoit, but it's a bit outdated. So this one is a bit newer, so we think might be better, but yeah.
Okay.
Just a short comment, since Nacho was not able to come, just for you to know that he has his first girl. Right, she's now 1 month and a half or so. So just this, he had to stay home. That's no, since you mentioned this, I don't know. I mean, the only thing, thinking about what you mentioned, Thomas, I agree. This stream, probably something is adding some text. They say, well, this string catalog is what normally is refer a data catalog in here and there in this context could help, because would make the document more understandable for depending on.
Absolutely, that's
Just
a perfectly
suggestion.
sensible input. Yes.
More it was announcing that Marina was in the
Okay.
around.
Good. Thanks.
So you're good?
Yeah. Good. Then let me jump to the telemetry message real quick.
Real quick, right?
Exactly. So just that's the overview slide, like the 5 categories where we use the node and data collector manifest, having metadata for the telemetry protocol, the optional network operator metadata, Yang push, the actual push update notification which we receive, and the subscription information where it is being put in the schema. So on revision 2, we had some comments from Reshad and Rob. Thanks a lot. And we had also changes from the Yang semantic versioning, which came in through the Yang push version updates. So there are some name changes. We changed the leaves from revision label to version and from model name to name. So the YAM semantic versioning is stable. It's now at ISG. So we believe this will be remain that way. So that's why we did the changes now. Now in -3, we received a young doctor's review from Martin, which we addressed. So we just was in time for this IETF. So far we don't have a feedback confirmation from Martin, whatever everything is addressed. So we did the following changes. Obviously, the identity name was not ideal. We changed from JP Push to Yang Push. He spotted that we had an identity ref which was not being used, and we missed that as a leaf. So that identity ref basically, that leaf describes basically whatever the telemetry message is actually being originated from the network versus cached and generated from the data collection. So we want to make this distinguish. And another important, and here we need your feedback, your confirmation. Martin suggested to change the message container to a Yang data structure or a notification. We had very similar discussions already on the Yang push envelope, and there was reasoning why envelope should not be a notification, it should be Yang data structure. And we believe that on the same reasoning, the telemetry message should be a data structure as well. So we applied that in 03, and Yannick will also show in the hackathon how that works out in reality. But here we would like to have feedback whether the decision to do a data structure instead of container or notification was the right choice. Any opinions and feedback? And I see Rob.
Yes.
Okay, good. That's very clear.
So, I mean, we've had that chat in private. Is there anything more that you can add as to why a structure is better than a container?
Okay,
For the
absolutely.
benefit of the working group?
So, to my understanding, basically, like a container is an object meant for in a Yang data store, data which is modeled in a data store, where notification is something which is coming out of a Yang data store being notified to somewhere, where the data structure itself is defining data which is other than the two things I was just describing. So since we are describing here not a notification which comes from the network, and neither we are describing a Yang data store objects, it's a telemetry message. So it's between a Yang message broker, producer, and consumer. We believe that the Yang data structure is probably the best choice. Sure. So the next step, so at IETF 1, 2, 3, we had already an implementation in the open source project NetGoes. Now, thanks to Paulo's support, and he implemented the document also on PMACCT, which is a network telemetry data collection. And we've seen in Yannick's presentation how that worked out. And there is a third implementation now, not the message broker producer, but actually the message broker consumer, so the opposite side, is being currently developed by Siena Blue Planet UAA, and we are working on testing there. And the only normative reference we have is on the message broker integration, so there is no other dependencies. And one question we like to clarify, and this was being raised not by this document, but another document, which is the message key document, which I will be presenting later, is whether this document the telemetry message should be an informational or a standard tracks document. The reasoning why in the message broker key we chose standard track is because in that document we are describing how the topic should be named and how message key should be generated, which is kind of an interface, an API between the producer and the consumer. And since the telemetry message is a schema and it's also basically relating to the same API, we think both discussions, whether it should be informational or standard tracks, we should consider both documents.
So we're out of time, so I think you should follow up on those things
Sure.
on the mailing list. Sorry, Rob, unless it's extremely quick.
Standard track.
Okay, thanks.
Thank you. Just bear with me 1 second.
Okay. Hi, everyone. I'm Yannick, and as Thomas said, I'm going to present actually how the theory works in practice. So we did the hackathon about validating this network telemetry message on two young push receivers actually. And that's the draft you see, and how it fits in the message broker integration. And on the right you see where you can get further information about how to configure and to implement, and exactly. And then we built basically on the results we had from the previous hackathon. So we had the packets, the young push packets coming from the young push producers, right? And they were replayed against the two young push receivers that then at the end should produce this telemetry message towards the message broker. Exactly, and so you find everything in this repository, including the configuration and the young schemas used for the validation. Okay, so this is again the big picture on how the young push to message broker integration architecture looks like, and our tests were performed on the on the point number 8, and the relevant documents are highlighted in yellow, especially also the fact to be able to validate any data, and how this needs to be also integrated in the toolkit. Exactly, so the first young push receiver was a PMACCT that we were validating, and we were using, and tooling is key, and so we're very happy to, I didn't do anything, but so yeah, we were using young lint from CESNet, and as a finding from the last IETF hackathon, we had requested to implement the support of young structure, which was delivered. So many thanks to CESNet for this. Now let me.
Yeah, should be good
now. Exactly. So that's it. And we're also happy to find some issues to show that the validation is really working. So the first issue we discovered in PMCCT was actually in the network telemetry message, there are only, in the metadata for network operator, there's only 2 data types supported for labels, and this is a string value and any data, and here the any data was not correctly encoded, and this we could catch with young lint. And then the second one was about timestamp format, which was also catched, which should be according to RFC 6991 bis. This was already updated meanwhile in the code. And the third one was about namespace missing here. Exactly. And then, okay, this was not explicitly mentioned. We then run into an issue with actually nested structures. So structure, any data, and structure. This seems to be a challenge for the implementation in the validation library. So this is something we're gonna address. In NetGoes, we did the same steps. And from the last hackathon, we're able to close some open items like the YoungLint structure support and PMA-CCT support for network telemetry message. Something that we need to spill over to next hackathon is the Young schema registry supporting Young features. And in NetGoes, the whole device-facing automation. And then we have new action items also for the next hackathon, which is actually in YoungLint to support any data and validation of nested Young structure, any data Young structure. So the second one is solved meanwhile, and then the other two bugs in PMA-CCT and the action items we spilled over from last IETF. And this was basically the team contributing to this effort. So many thanks to all of them. That's it.
Any questions?
Thanks. Thank you for leading this across the multiple IETF meetings. Great job.
It's on his chin, right?
Okay, good afternoon, everyone. My name is Qing Wu. So on behalf of the author, I present this topic, Young Data Model for Network Incident Management. So latest version is 06, and actually since in Madrid, we didn't get a chance to present, but since Madrid, we make several changes actually. The main change we made is replace root cause with the proper root cause, and also try to polish this definition, based on Adrian and Benoit's comments. Second is we replace machine learning with algorithm technique in service impact analysis definition. In addition, we try to further polish, explore how this young data model can be used in various different use cases in the appendix, and not a new use case, but we try to update this kind of usage example to explore how OSS can interact with network controller. And other changes, some editorial changes, for example, follow the INR template, Young model security consideration template, and also we add a missing reference in the Young data model. So, so in previous meeting, we discussed the definition of root cause. People have a little bit concern cannot have unique root cause, so we rename as the proper root cause. And based on input from linear from Orange, actually we add a reference from RTUT and also give the clear definition for the proper root cause. But based on feedback from Adrian, actually think we need to further simplify. So we try to provide simplify the definition. So the key changes we try to remove some complex context information. For example, inductive process related information, and also remove an RTUT related reference. And you can see the key difference between the previous version and the latest version. And we hope people can comment on this to help further we can simplify this definition. Second is about the definition related to the machine learnings. Also based on comments from Orange, actually think limit to the machine learning for this service impact analysis is not necessary. We have some other circumstances. For example, we can support automate reasoning or conformance checking graph traverser. So we incorporated this change in this definition. And for use cases in the appendix, actually we make several changes actually. For use case one, try to correlate between the troubleshooting ticket and the network incident. And so in this case, you can say OSS can interact with the network controller to do to demark the location of the fault. But the challenge is it may cannot demark whether the fault is on the user side or network side. So the solution we propose is we can extend the base network incident young data model. We can enhance this RPC operation to support the ticket number reporting. So you can see in the right side for each RPC we add ticket number new NIF, and so we can help her to the OSS to the better troubleshooting, locate the fault whether in the user side or network side. Second use case is look into the multi-domain fault demarcation. So OSS can be the multi-domain OSS can talk with RAN controller and RP controller in two different domains. But in some cases, for RAN controller can use update the notification report incident to the OSS, but still unable to locate the fault. So the OSS can dedicate the network diagnosis to the RP controller to further explore the problem. So solution proposed here, actually, we can make OSS to invoke incident diagnose RPC developer in the base model, and to further explore the root cause and provide a repair suggestions. So we give a extension example that it is diagnose key parameter. So you can see the list of the parameter. The last two parameter relate to the events and the related object. For related object in this left figure can be the base station IP address for the from the RAN controller. Related events can be the incident from RAN domain received from the update notification. So IP controller can correlate its, for example, net side port, transmission path, and network performance along the path, so they can do the better troubleshooting. Third use case is to support internet-based networking, and in some cases, the OS maybe need to spend multiple step use multiple step interaction to do the troubleshooting. Since some cases the controller maybe need more time to complete the diagnosis task, so we can allow OSS BSS to communicate in the a synchronized way. And so solution we propose, we can extend the network incident young data model to support a new RPC, and but this is a diagnosis task creation RPC is not in the base model, and so we can allow the OSS to send this RPC to the controller. RP controller can to allocate the task ID, just return the task ID, doesn't need to return the diagnosed task detail. But when the task get completed, actually either the IP controller can report the detailed diagnosed task to the OSS, or OSS can use netconf get config to look up the detailed diagnosed task. So that's it for the change we made in the appendix. And actually, just during this IETF week, I will receive some comments from chairs, and I think it's we address this some comments in GitHub. We haven't uploaded a new version, and I think we'll continue to polish this document. And also for this document, I think we like to ask chair to help her, to get more review, and also ask people to comment on this draft, so we can meet the time frame for the milestone. Yeah, thanks.
So one question I have as individual was, I mean, I provided some comments on the document last week. So I understand, it's not been updated and all that. But one of the things which surprised me a little bit when I read the doc was if I remember properly, the incident server creates the incident, but the incident client decides to resolve it. And I found that a bit odd because the server, based on alarms it's getting from the device, I assume, finds issues and decides there's an incident. And it wasn't clear to me from reading the doc, and maybe I've missed stuff, that the incident client had all the information available to decide that the incident is resolved. So you don't have to answer that now, but that's one of the things which I remember from reviewing the doc, which I found was there's maybe a gap, or there's a gap in my understanding.
Yeah, that's a good point. I haven't investigated detail, but I think this depends on how you implement this incident client and whether you more rely on the OSS to do all the troubleshooting, or you can more adopt intent-based networking concept, just let network controller to realize this intent to do more network fault management to. So this will clarify in the this incident young data model, so make it more clear and to try to address this issue. Thanks.
There's questions.
Hello, I'm Chongfeng Xie of China Telecom. I have one small question. You mentioned you had just talked about the demarcation in multi-domain scenario, right?
Yeah.
It is based on the assumption that this incident is caused by one domain, right? But maybe in some cases, an incident is caused by multi-domains.
Yeah.
Yeah. So in this case, how to deal with this case?
Yeah, that's a good question. So we just give some example how you can use this incident young data model. Yeah, if I think we have cross domain OSS or orchestrator, so they can connect all the information, incident related information from both domain, for example, optical domain, IP domain, so they can do the maybe leverage this AI related algorithm to decide what is the location of the fault, or if from both domain, actually I think they need to interact with both controller to address this kind of issue. So if you have good use cases, actually we can definitely
I will give I will at last session I will give like a share incident session about the case. So in that case, it's an incident by two domains. Okay.
Yeah, thanks.
I was hoping I was going to have time, but sorry, I was going to say I could steal 15 seconds from my presentation if you didn't give me time. But just on your question, the reason the client understands the incident is cleared is because although the server may think all the alarms have cleared and so on, it's only the client that can get the external view that maybe the fiber has been fixed and the repair crews have gone and all the tests have been done. The server can't know this. It's only the broader picture. So the client has that broader picture, which is why it then clears the incident.
Right.
If that makes sense.
But what about a case if the client thinks that the problem has been resolved, but the server is still detecting any alarms? Maybe the wrong fiber was fixed.
Then the client shouldn't be able to clear the incident. It should really be once all the alarms have gone, then the client now has the additional responsibility of saying it's now really genuinely gone because it has that broader picture. But it shouldn't be able to do it. You're right. It shouldn't be able to do it when the alarms are present.
Okay.
And if it did, then a new incident would come up immediately.
Yeah. So I think that part in the doc maybe needs some extra love. Okay.
Yeah. Thank you.
Hello, everybody. I will present the CMAP or SIMAP. A lot of people are saying SIMAP, and some of us are saying CMAP. So, draft in the name of the authors. So first, quick refresh. I have the slides here. Maybe I'll just go very, very quickly through them. Updates since the last IETF 123. And then some open issues and what next for the draft. And then at the end, maybe just some info about what next for the CMAP as a whole. So the draft, it was introduced as reference documents to have definition of concepts, different use cases and requirements. So I won't go into this. For those of you who are not familiar, you have it in the slides and you can read the draft. Overall, CMAP defines the core topological entities, their topological role in the network, properties, only topological and topological relationships, and both inside each layer of the topologies and between the layers. We are talking also about how to reference from CMAP external data models, whether they are young or other. So here's the list of use cases requirements. There was extensive discussions, contribution from a lot of people. And we also have a hackathon that was going on from IETF 120. And even prior to that, there was some POCs outside of hackathon. So the updates since IETF 123, we have 2 versions based on the feedbacks. There were some editorial changes and improvements of the definition for CMAP modeling to be more generic and maybe not RFC 835 centric. And then thanks, Rashad, for your detailed review and a lot of comments that you came up with. And, you know, in all of the sections, different comments. So some of them were clarification and some of them required updates. So those updates are in the last 2 submitted versions. So at the moment, we think we addressed all the comments that were there. In the previous version, there were a lot of issues that were on Git. We closed those, and now we address the Shepard's comments, and we think the document is ready for the last call. I think the milestone for submission was June 2025, so we are a little bit behind.
So unless I'm misremembering, we agreed that after the IETF, we would start the working group.
Excellent, thank you. Yep. And the last slide, just in general, what next for CMAP? After this document, we are starting to do modeling, young modeling for the gaps identified based on CMAP requirements. There will be a side meeting tomorrow at 6:30 in McGill for those of you who are interested in the modeling approach. So we have a draft submitted with some initial proposals, but would really like more contributions, feedbacks, reviews, and opinions to be heard. Then there are 2 drafts that Oscar and Victor are working on for, we are also, and others contributing for SPF and ISIS topologies. There is a draft Vivek CMAP external relationship that proposes how we can connect CMAP to the other young and non-young modules. And there is hackathons, there is a current hackathons and potentially future hackathons. Currently, there is a CMAP hackathon which will be presented on Wednesday, together with the summary from the side meeting that we will have tomorrow. And also there is a CMAP as a knowledge graph hackathon, included CMAP as a core in their ontology. And then for IETF 125 and future, we can look, the candidates are CMAP in anomaly detection and CMAP in anomaly detection inside the knowledge graph for operations. So these are some candidates that we are investigating as an option. Thank you.
Any questions on CMAP? Going once?
Thank you.
Hello, everyone. This is Luis. I will present the update of this draft on behalf of my co-authors. Just 1 second, please. So, yes, as said before by the chairs, this is one of the documents of the working group. So let me go through it. So basically, to recall the point, there was a chart, or there is a charter item in the working group about considering an update of the RFC 3535 about essentially to update the operator requirements for network management solutions. So you can see there the history of the draft. Would be this month will be 2 years that we started to work on it. So basically we started collecting an initial idea of requirements. Then this helped to fit the idea of the work of the charter of the working group. Along the time, there was also this workshop called NMOPs, where basically the draft also contributed as part of the topics being discussed there. And to the point that we have reached now to the adoption, and we are basically, as I said, 2 years from the beginning of triggering this work. So let me go through the scope of the document. Basically, the focus is on consolidating a list of new requirements and prioritize those requirements. So from the perspective of what could be relevant from the operator. So yeah, that we basically can focus on this work from now on. Just to recall that the report that was result of the NMOP workshop, it does not update the RFC 3535 requirements. So this is the scope of this document, basically. As said, the idea is to identify a very few set of actionable items. These items will be action in different, or could be action in different working groups and so. And the idea is basically to be actionable through the whole internet, whole IETF, sorry. And all of this is being done publicly available. So the idea is to be inclusive in the sense of collecting the views from the community in a broad sense. So everything is documented in the GitHub, and whoever is interested in it can contribute directly to that. So just focusing on the updates from the document, the point where the document was updated till now, essentially there has been editorial changes. So we removed the reference to RFC 3535 20 years later from the title. So now we're just focusing on update word. The authors in the first page was also reduced to 5. We moved some content that was previously in sections 2 and 3 to the appendix, and basically we have refined the naming of the requirements, so removing the new suffix from the identification of the requirements. Where we are now, so essentially we did an exercise of collecting requirements. We identified 24 requirements so far. I will not go through the requirements, but let me go through the categories. And I need to check my notes. So as you see there were identified a number of categories. Essentially, DM, that means that belongs to data modeling. Protocol, that means that requires protocol work. Deployability, that means that the impacts on deployability of standardized approaches. Integration, that means that has implications on integration effort by operators. SDO process, that means that requires some adaptation to an SDO process. Collaboration and cooperation, that means that allows better coordination. And finally, skills, that means that is relevant to skills transformation. So we did this initial categorization from these 24 requirements. And the next step was to identify for the set of operators working on it, what could be the overall level of importance for these requirements. You can see on your right that most of them, the majority of them, was qualified as a strong interest on working on that. So this is why we need to basically to start prioritizing them and trying to figure out what will be the different parts we need to start working with. So what's next? And this is the very last slide and probably the most relevant thing. So we need to work on this prioritization. You may be aware as well, we intended to trigger some discussion in the mailing list for this. A couple of mails were sent before the meeting. So to incentivize the discussion on it and get the views, collect the views from the working group. We have not received answers so far, so probably this means that the discussion is stable from the perspective of the working group, and maybe we can go broader of this broad working group to collect more information. The authors are discussing maybe different initiatives as could be go to or try to collect fora, feedback from other fora like LACNIC, Nano, GRIP, and this kind of fora, or even from other working groups in IETF as well. This next step basically means to document section 304, complete section 304. So far, what we have there is identify these 5 priorities, move much faster, implement minimal functionality, have running code, have vendors and operators on board for defining the work and validating things, and need to correlate data, learn from different means. IPFix, PMP, models, and so on so far. Our target is to update this section precisely and come back to IETF 1.5 with a more mature mix of prioritized requirements. And for this, we ask for your help as well to get feedback from all of you. And this is basically the point.
Thank you, Luis. Any questions? While people come to the mic, I've got one. So I was asking myself, what do you expect from this working group? Now, what I see on the bullet point is gathering feedback from working group. However, this is operator requirements, right? So I could go and say, this is what I would prefer, but I'm not an operator. So, and also you mentioned going back to RIPE, NANOC. So knowing that there are more people than just operators, what do you expect here? Because right now it seems like you're doing the work and you're going to do what? Validate it with operators only? So you see where I'm slightly confused?
I think whatever feedback is useful. At the end, operators can set the priorities, but the work should be done by all the community. So whatever feedback is useful for sure. But our point here is somehow we are stuck with the fact that we don't have more feedback than we already have. So we need to somehow collect more views to enrich
so more feedback on what? Because from the NMOPs, you had a good list of requirements from operators from everywhere. I guess that you don't want more feedback about new requirements here, or you just want feedback on the priorities.
The priorities.
I was just going to comment, actually, having feedback from the vendors who are likely to implement the subsequent requirements might also be quite interesting to say or hear. So if people sort of say these are requirements, it's like, well, we don't think these is any way we can fulfill these requirements. I think that'd be a useful input into this document. So I think having some sort of feedback coming back from the vendors might be useful in this document.
So you set requirements that you don't believe as a vendor that the operator needs?
No, requirements that we don't believe as a vendor that we'd be able to implement. As in we think they're intractable maybe and hence then is the requirement one you want to be setting or not.
Okay, with current software and current hardware, potentially, okay.
Thank you.
Thank you, Luis.
Okay, so this is the third document about the message broker integration. This is now a new document, an individual document. We have done a few weeks back already like a kickoff session with some folks who are actually working on implementations for the message broker integration and operators who will start using it. So we wanted to give some initial feedback and now here at NMOP we gone together also from the working group some additional feedback whether this is an interesting document to follow up on or not. So first of all, let me start where we are heading here. So a network engineer does a lot of show commands on network devices on the network to obtain the view of the network, the state of a routing table. It's almost impossible to log in to all the networking devices in all routing tables and basically collect through show outputs all that information and somehow assemble that all together, right? What we are aiming is that network state we want to get directly from a message broker topic. So not to do the show commands on the router, we're going to do the SQL command on a message broker topic. So we have not the device view, we have the network view consolidated in one place. We don't need any access to the routers. We don't need any database. So this is a digital twin enabler and no rocket science what we are showing here. First, let me do some basic terminology that we understand each other. First part is about message broker. So a subject basically relates to a schema. So these are messages based on a common schema, and these messages are in a are sent through a communication channel between a producer and a consumer. That's called a topic. That topic can be load balanced or spread among different message brokers, and that's called partitions. And these partitions, we're going to have small informations. They are called segments. So each segment can have one or more messages. Each of the messages can have a message key, and the message key is being used for indexing the data. And then last but not least, based on the message key, we can actually compact topic. So compaction in data, it's about reducing information to the latest state. And yeah, Richard has a question.
So I think it's a comment I gave on the list last week. It's when I read the doc and I saw subject. For me, subject is a schema. I associate subject with schema. Is that right?
That's correct. So that's basically the message in a topic, which relates basically, or messages which relates to the same schema.
Yeah, because you're basically trying to get multiple messages or schemas, message types in the same topic. So
correct. Maybe I'll give an example, like very probably more familiar is Yang Push. Yang Push has one session between the publisher and the receiver. However, it has multiple subscriptions. Yep. So subscriptions means here subject.
Okay, I still struggle with it being called named communication channel, but maybe that's just okay.
Different domains, different namings. So let's go towards Yang data taxonomy. So Yang, and here you see it on the right, is dimensional data. So data taxonomy means we have a tree. What I'm showing here is actually a Yang schema tree. Each of the items you see here, these are schema nodes. Now with RFC 9254, for CBOR, we have now the term Yang items identifier. So each of those Yang nodes can be a Yang item identifier. However, also other items in Yang which are not in the schema, not a Yang schema node, can also be a Yang item identifier. So in this document, we came up with a new term, which we call Yang index, which is a subset of the Yang item identifiers, and it's only the Yang nodes of is the subset of the Yang item identifiers. So everything which I was just describing, apart from the Yang index, is already well-known terminology. Now, let's go briefly how Yang Push works. So we can discover what we can subscribe. Then we can make a subscription. And in this example, we have two routers, two nodes, router 1 and 2. Both have exactly the same subscriptions. So we have a periodical subscription on the statistics on an IETF interface, and we have an on-change sync on start subscription on the IETF interface itself to get the inventory. Since subscription IDs are locally relevant, we give them different ID numbers. So Yang Push 1, 2 on the first node, 3 and 4 on the second node, or in other words, subscription ID 1 and 3 and subscription ID 2 and 4 share the same schema tree. Now, sharing the same schema tree, so when the Yang Push receiver received those schemas, and then in the data producer goes towards the schema registry and register them, the schema registry doesn't give us back 4 schema IDs, it only gives us back 2 schema IDs because it does schema comparison. It sees that subscription ID 1 and 3 has the same schema, so it's now schema ID 11, 2 and 4 is schema ID number 12. Or in other words, subscription IDs are locally to the node relevant. Schema IDs are network-wide relevant. Now, going to what we have today, if we would not not implement this document. So we have one topic for Yang push data. So basically the session between the Yang push publisher and receiver is directly translated to the topic, the communication channel across the message broker. Each of the schema, so we had before schema ID 11 and 12, is then mapped to a subject in that topic. Or in other words, we have one giant topic with many subjects. Now, that topic goes across 4 partitions. So it's like networks with ECMP paths. It's being balanced over 4 partitions and goes through different message broker nodes. And we have one or more messages which are being saved in a file which we call segments. So, in other words, with the 2 existing documents, we resolved how we're going to integrate. We resolved the schema between the producer and the consumer. However, we did not resolve the problem of how we address the topics and how we do message indexing. That's what we're about to describe. And I see Rob has a question. Sorry, I did not notice.
You can take it at the end. I was going to ask about the deduplication process, if that was Yang specific or not, but you can take it at the end if you want.
Okay, yeah, we can do now or.
Okay.
Mm-hmm.
So the question was whether the deduplication that the schema registry is doing, is that Yang specific?
Yes.
So it's sort of normalizing the Yang schema and then doing the dedupe.
So it's the schema comparison. So
Okay.
Okay. Mm-hmm. So now what we are proposing is basically that this is not, we have one giant topic, we have now multiple topics, and we have one topic per schema ID, or in other words, there is only one subject in one topic. We're going to explain how we do the topic naming concept, but also we're going to explain in the topic how we do the message indexing, so how the messages are deterministically indexed among the partitions. So message keys and indexes. In red, you see an example message key, how it's being indexed, and the text describes how that index is being created. So we saw before that Yang is has a taxonomy, has a schema tree, so each Yang node is uniquely identifiable. So we take that Yang, those Yang schema nodes and use them in the message key generation. Now for the Yang push message broker topic naming, and here also in red the example. So first of all, in message broker, the topic naming usually starts with a project name, with an environment. So is it production? Is it test? And then from then on, you're getting more and more specific. So similar like a host name in the internet. So you see in the red, we have statistics and Yang, and then basically the name of that, let's say, specific Yang schema. So we propose that in Yang push, we can subscribe periodically on change and on change with sync on start. So here we distinguish that periodicals are statistics, on change are state changes, and on change sync on starts are states. And then next level is Yang data. So we have statistics, Yang, and then basically the schema ID or the schema name. So that means when the schema registry feeds the information into a stream catalog, what schemas are available, now a user or an application can discover through the stream catalog what is available and find out which topic and which subject it can consume. And Reshad has a question.
Yeah, so going back to this, when you showed that at first, it wasn't clear to me why you needed to go from one topic for everything to one topic for schema. Is it because you want the key to be unique between the subjects, or is there another reason?
You give me the segue to the next slide. So we are gaining two things, and that's written in green. So with topic compaction, we can basically reduce the messages to the current state. So, and in order to do a topic compaction, we need a key. If we have multiple subjects, we have multiple keys, doesn't work, right?
But when you have multiple topics, are you worried about misordering, or are you going to use timestamp?
Ordering is already preserved in a message broker. So there are message IDs, and I don't want to go into detail here, but basically the message broker itself already takes care of that.
So the consumer of the messages make sure that they're processed in the order they're
exactly. Now the second aspect.
Sorry,
there is Nigel. Sorry, yes.
So on the compaction, you using any compaction delay at all, or are you just going for instantaneous and vigorous compaction?
So you're asking how compaction is being done in a message broker?
Are you considering delaying? Because you can have a delay.
Delaying. I think you call that lazy. Like
there's also lazy is how much compaction it actually does anyway, because it can leave 20% of the log not compacted, but you can also delay compaction start. So you can have it not compacting, say, for a certain number of messages or a certain time period. So it can sort of leave a buffer of recent changes. So you may still find it goes property A goes 1 2 1 2 1 2 1 2, and then you start compacting it after some period. So you get
this is exactly what the message broker usually does. Yes, exactly. Now, the second optimization which we have here is basically before, when we had multiple subjects in a Kafka topic, and I'm only interested in one subject or even just one subset of a subject, I needed to consume everything and drop basically everything which I'm not interested in. So now what I can do is only consume the topic which I'm interested in. First optimization. Second optimization, I can go even one step further. Since I know now basically how the message key is being generated, I have deterministic keying. And that means based on that deterministic keying, I understand that these two nodes where data is coming from out of thousands of nodes, that data is on those partitions. So from that topic, I don't need to consume from all the partitions, only from the partitions which are relevant for me. So even reducing more how much data I need to consume. Or in other words, think if we go back to the initial slide where I said I'm doing a show command on a network node, that's relatively very small information, right? And if I do that network wide, and I do not have that overhead anymore, then basically that show command, that SQL command I'm doing directly on a message broker topic, gonna be very effective and very quick. And we are in the real-time streaming business here. Nigel.
Another one. So with compaction, obviously, if you start with the oldest message, I think it's the head or the tail, I think it was around they do it, and you drain the stream, you basically are up to date with current state. So
correct.
But if the challenge in there is when I'm maintaining alignment, if I disconnect, then I can go back to my previous. What do you do with tombstones or deletes? Do you have a delay on a duration of those? Because obviously if you lose any of those, then you have to go back to the beginning of the queue and realign. How are you dealing with that? Is that written up or?
So I think you're having two questions in
Yeah,
here.
it
So
twisted into one
one thing
question,
is,
yes.
let's say a database is consuming data from a message broker,
Mhm.
and the table just go bust, trashed. I just need to refetch the data, right?
That's right.
So the concept on a message broker is you have a consumer group. So if I want to basically reconsume everything again, I need to have a different consumer group ID. So I change just the ID. That's one thing. And the second thing is, so I have the choice on which topic I want to do topic compaction. So if I want to have a topic just with the most recent information on most recent state, I can enable topic compaction. If I want the entire history, I can go way back and set the retention
I was
time.
thinking with compaction, but then with compaction, I've still got the tombstones or the deletes that I've got to worry about, and I can be quite a long way behind on the queue on the topic, but still regain alignment by reading the topic, as long as I haven't lost any deletes, and there's a time period for that too, in which case I then have to abandon the attempted maintenance alignment. I have to go, yeah, okay.
Exactly.
Is that all written up? Is that
So-
written up in the?
No, that's not
Okay.
written up in the document itself, because this is the way how message brokers are doing. Here we are just describing the context, how we should index, how should we do the addressing in terms of context. And Camilo, yeah.
Yeah, hello, Camilo Cardona. I will it's just a recommendation.
Sure.
For the examples of the index in compaction.
Yeah.
Please, I know it's appealing to use interfaces because it's simple and everybody knows it.
Sure.
But please use something more complex.
Of course.
Like quality of service, in which you have multiple queues.
Yes.
And in different parts of on the path, and hopefully one list that at least has two keys. Just for seeing how it works in that case, even though I see that there's no limitation there, but just in case, just to have a better,
Right.
a more
I'm
complex
just
example.
jumping a bit ahead. So one of the next step items is basically we want to take different examples, basically from subscription, from schema trees. And then based out of that, we want to generate message keys and also topic names and see whether it makes sense or not, right? Good.
Yeah. So Holger, go ahead, and I think we said we're going to take a few more minutes.
Okay.
So you're good. You don't have to.
We
rush.
got some time.
We got some time, and
Oh,
this is an
okay.
interesting.
Good. Thanks. So, Holger, yes,
Yeah,
please.
Maybe I should wait until you're finished and with my question. I think it's a bit off topic.
Up to you. I mean, if it's okay, good. So here just like 3 example use cases. I was mentioning in the beginning, the network engineer doing a SQL query, so to do a change, a maintenance window verification. And as a network controller who wants the current state from the network, doesn't need to access the network anymore, just the compacted Kafka topic as an message broker topic as an example, or other use cases like the network anomaly detection system to get the current management state metrics, and actually building the network inventory model could be also a case. So these are the 3 documents. Then next step is we want to get more feedback. We want to widen the group here. Also, as Camilo also mentioned, we should test it against different, more complex subscriptions. Somebody is interested to contribute some test code to actually prove that this is implementable. Please let us know. Contributions are welcome. The questions on informational standard tracks, I think we already have some feedback in the chat, and then from there, when there is interest, going towards working group adoption, and from there, once we have the proof of concept, go towards actually implementing in data collection. So continue with netgoes and PMA CCT now beyond the telemetry message, and now also towards topic name and also indexing. That's all. And Holger, yes.
So Holger from DT. Obviously, I like the idea, but my question is, if I have some restrictions from the message broker, if I'm not allowed to create a topic, if I am allowed to create a topic, but I need to define a producer that is allowed to write on the topic, if I need to define consumers, this is somehow missing in a document yet. Should we add it?
So let's say I think that's not really needed in context of how Yang should be integrated into the message broker. I can only say that normally message broker allow that you can, by creating new messages into a new topic, that the topic is automatically being created and there is a default configuration for that topic. So that's a way of doing it. But there are also other APIs, how to interact with message brokers to create actually that topic. But these are all message broker specific. I'm not sure whether we should describe that as well. And that's why I was mentioning in the beginning, like the Apache Kafka book, there basically these things are being described for Apache Kafka itself.
Okay, thank you.
Sure.
So I don't mean to jump the queue, just say I'm going to start a poll. No, Rob, you can go. I'm going to start a poll to get an idea how many people have read this document. Okay.
So Thomas, thank you. I think it's a great presentation. I think it's really good, really interesting. So and I'll intend to read the slides in more detail because you've gone through them quite quickly, but I think it's great what you're doing here. One of the questions that came up in NetConf earlier today when I was presenting on Yang Push Lite is, why do you use Yang Push Lite rather than GNMI? And I think that this is a great example as to the fact that you're building an end-to-end solution that's getting the data not just from one hop from the device to a single consumer, but out into a wider system where you can then consume that data. And if Yang Push, for example, is inherently better than GNMI for various reasons, that's a compelling reason as to the market as to why this is a good solution. Because I think people will want to implement this and they'll get the other bits that come along with it because it's there already.
Absolutely. And one example, what you just have said is, for instance, the discoverability, right? We have in Yang Push the way of discover what can we subscribe. Well, the same thing we also have with streaming catalog. We can discover what we can actually subscribe on a message broker. So you see when we are doing these things end to end, things are really seamlessly integrated.
And then I had two other minor sort of technical comments. At one point, you use the term statistics to describe one of the three.
Yes.
It feels to me that could be very confusing because you might well not be getting statistics. So maybe she's a different term there.
Sure.
And then the other one I was thinking about was you talked about partitions and how you could optimize the partitions. I don't know how Kafka works,
yeah,
but I wondered if that's like a layer violation in terms of is the fact that the partitions can be added and removed dynamically. I don't know if that's a possibility with Kafka, that you may not want to do that. I don't know. That was just a thought.
There are actually, let's say that descriptions and articles when basically the amount of partitions on a topic are through the life cycle are changing. What are the implications and how to deal with those implications? Could be something we could add as an information to the document, just to give an overall overview, like, hey, these are the challenges in such kind of an environment. Yeah.
Maybe it might be too much detail, but thank you.
Sure.
So one question, your first slide, I think, says no network access needed and no database access needed.
Yeah.
The second part surprised me a little bit. Are you trying to remove database access? Is that a goal? I mean, I'm not questioning whether one should or should not have.
So I can give an example when we developed anomaly detection. So when we were in a POC mode, we ingested all the data into a database. And since you periodically need access to that data in real time, it's a lot of time you're querying, you're polling, right? So therefore, databases for automation in analytics, they do not scale well. So usually databases are being used more that humans can on demand accessing the data, and not only the current data, but also a bit more historic data, more recent data. So therefore, streaming scales higher. And if possible, we want to have everything in streaming. And this is where the industry is heading to. And also there is more and more a blur about streaming versus storing the data temporarily in a time series database versus having them for long-term stored. So
Just a short question that maybe is extremely naive or not, I don't know.
Sure.
It's about when you mentioned this idea of making the document informational standard track. Have you considered other message brokers apart from Kafka?
Absolutely. So we were mentioning two message brokers, Apache Pulsar and Apache Kafka, because like Apache Pulsar is a bit newer than Apache Kafka, and everything which I'm describing here works on both message broker, but there are others. So most of the things are supported by most message brokers, like topic compaction, not by everyone, because that's a bit more advanced, but these are really generic
the
terms.
key part, no, that was my concern.
Exactly.
Whether it was perfect.
And I was showing the picture of NASA at the beginning in the 60s.
Yeah.
So what we're doing here is no rocket science, okay? So it's all existing.
Well, no, this is old-fashioned rocket science.
Exactly.
That's it.
So one last question that's as chair, not individual, is I think we've had that chat many times. There's going to be no normative references from message broker to this doc, right?
That's correct.
Okay.
Hello, everyone. I'm Daniele Ceccarelli from Cisco. I will give you a short update on the AI-based network management agent concept and architecture. So this draft wasn't presented at the last meeting, so I thought it would be a good idea to give you a very short recap on background, scope, goal, etc. So background: the concept of AI agent is something that is widely deployed nowadays. There is plenty of examples in the industry. TMF autonomous networks is just one of the many. The scope of this draft is to define an architecture, a framework for AI agents in the network management area. And we have three goals. The first one is to define a framework for NMA, network management agents, clarify the relationship between NMA and the existing controllers, because NMAs are not going to replace what we have today. They are an addition. We are improving our automation suites with agents, and not just the relationship with the existing controllers, but the existing work, RFCs, tools, and so on and so forth. And the third one is to specify functional requirements that NMAs are introducing in our network, specifically in the interfaces area. Obviously, a non-goal is to specify agent implementation details. That's out of scope. Let's start with the definition. Actually, I don't know if you recently read the draft. We spent some time to improve the definition of NMA, which in a nutshell is AI agents for network management. Basically, an NMA is a network management entity which uses MLA, machine learning, artificial intelligence, and is built with the purpose of creating autonomous closed loops in the network. An NMA interacts with, as we said, a lot of different tools, components in the automation suite that go from execution, perception, planning, decision making. So all the different components of the automation suite. And if we look at the three pillars that build closed loop: insight, decision, and action, the NMA component basically maps with the decision component of the loop. And what about the relationship with the pillars of automation of network management? If we take, for example, RFC 8969, which defines a framework for automating services and network management. The scope of NMA is not to replace it, not at all. It's just to increase, to augment the capabilities that are introduced here. So you see that we have the different types of modeling at device, controller, and orchestration. Where does NMA sit? Basically, they can be found both at the controller level, at the orchestrator level. And there can be multiple of them, so that this introduces two types of interfaces. NMA to NMA interface, which is what we call intralayer, and NMA to NMA interface in a hierarchical fashion. So an NMA at the controller level interacting with NMA at the orchestrator level. And this is what we call A2A interface. So we also try to define two different deployment models, the independent one and the integrated one, each of which with pros and cons. And you will see that, I mean, from our point of view, we are leaning a little bit towards the integrated mode. We also had a discussion on the mailing list. Thanks for raising the point. But for sake of completeness, we discussed both of them. So in the independent type of mode, we have a separate deployment of the network controller and the NMA. And this introduces three new types of interfaces. The northbound of the NMA, which we call the A2U, agent to user interface. It's basically the interface that is used to issue call request from the user to the NMA and to return the result of a processing result. The A2C interface, which could be a little bit cumbersome, is the interface between the NMA and the network controller, which in the independent mode is an external interface, while in the integrated mode is internal and probably doesn't need particular focus, particular effort from a standardization point of view. And then the agent to network interface, which could be the source of problems here. In the discussion that we had on the mailing list, the comment was, okay, but having the NMA interacting with the physical network could be source of misalignment between the network and the network controller. In theory, there are ways to avoid this misalignment and create, let me say, and keep the controller aligned. But this could work or not. This is the reason why we thought that the integrated type of deployment was more efficient. In this way, we are not going to replace the controller interfaces, but augment it with NMA needs. And this is something that we are addressing a little bit thoroughly in the draft, and where we think that there is the need to put our standardization effort. In fact, the question, one of the open issues that we need to discuss is extending the controller NBI to support this capability of invocating the NMA interaction with it. Is the right way forward? Are we on the right track? And if so, what is the interface or protocol that we need to use? Is it going to be netconf and YANG, HTTP and JSON, or the de facto standards that we have in the industry now, MCP, A2A, and so on and so forth? So, obviously, in 10 minutes, we didn't want to waste your time, waste the time in going through all the requirements, but you can find them in the draft. And if you wanted to discuss them on the mailing list, that's absolutely what we are looking for. In fact, for the next steps, this is what we are aiming: improving the content of the draft. If some of you read the first versions, you might find a lot of new text stuff that we put there. collecting comments and contributions from the working group. And then, so we believe that a framework and architecture is a pre-requirement for all the work done on AI and agentic agents in general. So the draft is absolutely far from being completed, but we believe it could be a good starting point for the working group to work on this topic.
Thank
we
you.
have 2 people in the queue.
Right, a quick one, because actually I was just writing down all the things that I learned. AI agent, network management agent, A2C, A2A, A2N. I was looking up the side meeting this week. AI network, AI agent discovery, AI agent protocol. There is RTF, there is IETF. I believe at some point in time we might need with guidance on where we're doing which work, right? Because I'm sure we're going to receive the same type of AI-related stuff everywhere. So it's a question like, is it contribution for up? Don't answer now, right? But this is like a generic statement for the week.
At least it means that there is interest in it.
So maybe rather than an IETF, we need an AITF. But I actually had a serious comment. On your previous slide, you were saying about what's the best way of doing this, what's the right interface protocol. My gut instinct here is 2 things. One is we shouldn't put this into a specification. We should put it somewhere else on GitHub and do it dynamically. And 2 is I think we should build on MCP or A2A. These ones have a lot of traction in the industry and they're moving very, very fast. And I think that if we try and do something like netconf Yang, we'll be so far behind by the time we get it done. We have to follow the flow and know that that's changing. Hence, this document, to be useful, I think, is specifying the sort of requirements and behavior, but the details of how it looks, that has to be something that's going to be changing quite dynamically, is my thoughts.
I raised the question, but I completely agree with you.
We don't hear you. You have to go to the mic.
Those 2 things are not mutually exclusive.
Okay, good. Thanks.
It's hard to follow AI IETF. So I've actually been building agents. I built one for the NOC here. I tend to agree, MCP, and in that regard, I think independent makes more sense to me in my head because it allows me to plug things in and I can have an agent that understands controller A and controller B. And the other thing I would caution you against always going to this closed loop. Don't make it mandatory that the loop is always closed. There should be the ability to have oversight if need be in here. And the goal shouldn't always be to autonomize everything.
You're absolutely right. So with the term closed loop, I don't mean something which necessarily keeps the operator out of it. In the sense that there could be cases where there are just insights that are provided to the operator and the operator decides what to do. I don't know if you call it that closed loop or not, maybe. So it's a semantic thing.
All right, Mahesh, I just wanted to acknowledge that I'm glad the question has come up early in the week on Monday itself. So hopefully by Friday, we have an answer.
All right, very good. So actually, we have to close. Can you just drop your message on the mailing
one
list?
question. So what's the role of agent in Kachuna? What kind of function can be provided by the agent in Kachuna?
Anything from analyzing the configuration of the network to implementing any type of use case. You can use an agent
But I
for
think
everything.
this requirement is not clear.
Yeah, so thanks for the question. Please follow up on the mailing list. Thank you.
Thank you.
Take it in your hand if you want.
Okay. Hello everyone. I'm Lucia Camanillas, and together with Diego and Ana, we prepared a new draft titled Model for Distributed Authorization Policy Sharing. But let me start first with the why. As you all know, today's network and service environments, even agents, are no longer centralized or static. They are distributed and automated and often span multi-domains. In such complex environments, authorization policies are everywhere, but the problem is that they are all fragmented. Each domain, each platform, each environment manages its own policy languages with each format, tools, which makes it really hard to validate, version, or share them. And even worse, the lifecycle management is inconsistent. There are some policies that are manually updated and some others that now untouch us until something breaks. And as we move towards more automation, these manual or static mechanisms simply don't scale. So what we will need is a common model for expressing, sharing, and enforcing policies in a matching, readable, interoperable way in heterogeneous systems. So what I have been working on is whether Jan could serve as a canonical representation of authorization policies. Jan already provides us a well-structured, extensible modeling language that could be useful here for representing authorization policies in a consistent, matching, readable, and shareable way. On top of that, we treat policies as code, which will allow us a fine granularity, policies even at the data level, and as it is code, you can do whatever you want. Policies can take into account context information, which is essential in network environments where policies may need to adapt dynamically based on the context, such as risk assessment, the topology, contextual information about the request. So the idea will be to cover the entire policy lifecycle from creation and validation to versioning, distribution, and decommissioning. And something that I wanted to mention as well is that we should think about what we like to take into account in the authorization decisions in our network environments, because policies may consider the claims encrypted within the tokens, and there are other groups already defining the information that should be included there. So we need to be aligned to make sure that these tokens include the information that we need or our minimum requirements. So this will be the architecture or the workflow where the policy author will define the policy in YAML format. Perhaps in the future, we may even consider that these policies are sent as an intent and then transformed into YAML format, or even generated by a network agent. Then we have the policy administration point that will validate the policy schema, optionally verify the provenance, extract the embedded policy as code logic and distribute it to the corresponding PDP. And finally, the PDP will evaluate the policy as code and produce authorization decisions. This is how the YAML module looks like, where each policy will include metadata, such as the identifier, the version, or the policy language. Then we have the declarative logic. This will be the policy as code, which can be expressed, for instance, in Rego or CIDR, which are different policy languages that are based on the concept of policy as code. And optionally, provenance information, for instance, using cause signatures. There is another draft on signing messages modeling that could be useful here. So that's all. This is the very first version of the draft, so I am open for feedback. The idea will be to gather as much feedback as possible, and as next step, I would like to refine the model structure and YAML modules, explore the integration with provenance mechanisms, and work on a reference implementation to be demonstrated at the next hackathon. And the question will be, are these identified life cycle and interoperability requirements relevant? I am addressing the right aspects. That's all.
Daniele Ceccarelli, this time as IV chair. So first of all, I beg your pardon, but I missed the draft, so I have not read it. I'm just asking based on the presentation that you just gave. I was wondering about the relationship between this work and what is done in Ivy with respect to capabilities, entitlements, and so on and so forth. Is there a relationship between the two things? If so, what?
To be honest, I was not aware of that, so...
One-to-one.
Yes.
And second thing, welcome, because we had enough of Diego and Luis on the stage every time.
Okay.
Thank you.
Well, potentially yes, but it's not intended to. I mean, the point is that when we're talking about capabilities, we're talking about what you can do, but not how you are controlling or whatever. Some policies may refer to capabilities. If we have a formal mechanism for expressing capabilities, we could refer policies to capabilities, but not yet. Here, what we are, the main intention here is to have a focal point. I mean, it's like, think about this. If you think about this, it's a little bit like going a step forward with everything that has to do with SDN, etc. You have a central control point that distributes the configuration and mechanisms. So moving it a step, evolve in the hierarchy and doing something similar with policies. And making it verifiable, machine readable, etc. That's roughly speaking the idea. Then we will talk about capabilities later on. That's next. Later on.
Thank you.
Just give me a minute.
Nigel, you've got 6 or 7 minutes.
7. Oh, wow. Thank you. So I've been given 2 extra minutes. So Nigel Davis, on behalf of the authors, there are 2 drafts, one here in NMOP and one in Ivy. So we're doing that bridge. And there's 2 references on this. One from ITT. There's also an ONF readily available document. And there's an old draft I have, which expired, that has related information in. I'm talking on here framework for capabilities. In Ivy, we were talking about specific examples. I get 15 minutes in Ivy, so I've got more time. So that presentation, if you want more detail, we can do it there. Click. Oh, that's the pointer, isn't it? There we go. So what's this about? Capability is a description of what can be done, so what a thing can do. There's 2 sides to this, obviously, what something can do and what it needs to be done for it. So both of those angles. RFC 3535, which was talked about earlier, actually has a requirement in it for devices to express their capability, but going beyond that, clearly you need to know the capabilities of something prior to the thing arriving, because I want to buy it, what does it do? I want to plan it in, what does it do? I haven't got it yet, so I can't just discover it from the device. I have to know about the device's capabilities up front. Not just devices, it's any component, any function, and so on. So it's about the functionality. In a physical space, it might be about its physical properties, what it can support or what support it needs, and so on. They're all capability expressions. And the purpose here is to look for, as it says down the bottom, a framework. So we're looking at that here. How detailed? Well, if I say it's a router, that's clearly inadequate. It's like saying it's a shop. What does it do? What's it sell? What property? Is it a cheese shop? Is there an expert in there who can tell me about cheese and so on? I've got to go a lot more detail than just it's a router. How far do you go? It depends on what your specific need is. You can, sometimes it's very deep, sometimes nowhere near as deep. The difficulty is determining how to express that and what the mechanism for expression is. So the goal of this specific activity is a cohesive framework. So it's to develop a framework for expression to determine where we've got language today that can help us describe the capabilities, where we've got language missing, which we need to enhance. Obviously, we can take Yang as a core, but there's elements that maybe Yang can't do for us that we need to extend and so on. Looking at the diagram, capabilities in terms of the environment, so in terms of green considerations, in terms of how much power I use and so on for a particular function. regulation might express restrictions on what you're allowed to do. Operator policies likewise. We've got requirements we talked about entitlements. We've got requirements in entitlements. I've got to understand what the thing can do to be able to offer, to be able to say what you're allowed to do with it. If I can't understand what it can do, I can't restrict what you can do or allow you to do things. And obviously in our plugs work, we've also got a requirement to understand what the plug can do, and again, before it arrives. So I've got the coverage would be a framework to deal with any components, capabilities, any components, needs, and so on. The approach we're taking here is not just to do a framework and not to do some blue sky exercise that looks off into the distance, or we've got to do that, not just to try and look forward, but also to take things now. So the intention is to develop examples that we can use to help us understand the mechanisms of expression, what needs to be expressed, and to develop in a gradual value added way. So we develop something in Ivy. This would be much more a practical position where we're looking at actual components and actual capabilities, so we can develop the framework and the actual expression usage of that framework for a particular purpose in parallel. Now, clearly, we've got to have an idea of where we're trying to get to as well. So it's one of those difficult things. We can't just go and spend 5 years trying to develop a wonderful framework, and we can't immediately hack some solutions. We'll be back to the drawing board again very quickly. So it's trying to run those two things in parallel, and hence the two groups. So NMOP here for the framework and Ivy for the specifics. We're also looking at using, as I said, mentioned some of the work from other bodies. So the stuff in ITT, there's some useful patterns there. And Vim's going to talk on meta model, or whatever it is now. I can't remember the titles anymore, sorry. But there's the work he's looking at there might be useful. We might also want to take advantage of some of the component system patterns stuff we've done in ITT and ONF and so on, which is a useful generic recursive pattern, which we can use in the framework, I would think. So initial focus is device capabilities in Ivy, entitlements, and also looking at plugs in Ivy. So, and then, as I said, framework here. Click, no click, that one. So, okay, so that's all I had to say. I want to leave time for some questions. We're working plugs, green, entitlements, equipment, and the framework here. Join us. We'll have some stuff on the mailing list, so I get more time next time. So we'll go on the mailing list after this and start, requesting, putting points forward and requesting questions and so on. So, anybody have any questions on that?
Yeah. So I took a look at the doc last week, but I've looked at many docs, so I might be confusing some of the docs.
Yes.
Where am I? Yeah. So what's the overlap between that for device capabilities and RFC 9196, which seems to address exactly that for system capabilities? Is there
we would be taking that sort of work on board and then trying to generalize that and also drive that into the device. I don't see any reason why we wouldn't.
Okay.
I mean, we're taking input at the moment, especially since this is obviously new, so we've not presented this before. We only got the draft out a few moments before the cutoff. So, but yeah, we'd be taking on board. And if you've got other references as well, that would be useful for us to be able to sort of pool material. So yes.
Thanks for bringing this. When people say capabilities, I think they mean many things to many different people. So I think it's a complicated problem space. And there's certainly some aspects of this work I think definitely need to be addressed.
Yes.
And some of that is partially already being addressed already. My one fear here is that you end up creating a really complicated system, and that it becomes too complicated. And I think you're right in saying you need to do these two things in parallel. You need to be bringing like an implementation and solving the simple problems at the same time. And in this whole problem space, I would try and not solve everything. I would try and solve the low-hanging fruit first. That's right. Get that working, and then build it on very quickly, because otherwise it'd be
that's right. You can spend forever on the theory and never get anything useful out of it, and that's pointless.
Or build a system that's so complex that nobody wants to deploy.
Because that's a really important point as well. When I said it's a router is inadequate, it's not inadequate for some parts of the problem. So a very, very simple solution can provide value.
Yes.
But it needs to, and I think if we get the framework right, we'll have this fractal recursive thing. We can keep opening up as far as you want to go without it being horribly complicated on the surface. So that's the sort of thing we're looking for, something that looks
All right.
simple when you only need something simple, but has the opportunity to open up. So I go away now. Okay, thank you. Thank you.
Thank you, Nigel. It was not the message, but it was the message. Thank you, Nigel.
All right. Yeah, thanks for having me. I was a bit late to the party, but so this work is actually, I presented in the Ops area working group last IETF, and I promised that I would write a draft. So actually this is the result of it. So this draft, at the moment, I'm the only author, so there will be more people joining this draft going forward. But so basically what it is about is, so I first of all, this work is based on actually implementation. So this is not theory. So this is actually practice. So the draft basically talks about or has basically two concepts in it. One is a generalized framework to define modeling using graphs, right? And the second piece is actually a way to, typically when you do automation, is to how to have a set of API operations that allows for, I would say, multi-actor or being able to do things in parallel, but also to basically offload between what the client does versus what the server does. So if we have more generalized capabilities, what it actually means is actually the server can do more on behalf of the client, and as a result, the implementation becomes more simple, right? So that's kind of, so both of these two things are there into the draft, and that's what we are trying to describe and then eventually standardize. Now, conceptually, so the terminology, so I took the graph-based terminology. So we basically have an entity of a resource, right? Which is basically a node in a graph. So typically a graph has a node and then an edge. So it's basically the connection between two nodes. So I use the terminology of a resource. So the resource is basically the definition of an API or the thing that, or the what, as I try to explain it. So typically that is backed up by a schema. So it can be Yang, can be OpenAPI JSON schema. So the idea here is also to be, let's say, that's why we introduce a concept of the meta schema, is to not try to reinvent those modeling languages, but use them and try to actually connect the data using various modeling languages that have been used in the industry. And as a result, have a generalized mechanism to actually connect the data together in a generalized framework. The second piece of it is the relationship. So it's basically how you connect those two things, right? And basically the draft introduces a unique identifier on how you actually identify a resource, and then to be able to describe it using constraints or particular metadata on how that's how those resources are connected. Now, so this is another representation of the system, right? So it's basically what you see on the left-hand side is what we typically do today. So you typically have a modeling language, being JSON schema, OpenAPI, or Yang, right? And we try to basically, so in the model itself, we typically have those resources today, right? And so what we do is we use the same technology to describe and we connect those resources together. So if you take Yang, you have leaf refs and stuff like that to be able to do so. But what you typically then end up with is that you actually, that model becomes very specific to your use case. So if you want to extend it, you actually have to change the model, right? So with the approach that what we are introducing here is that you can still do whatever you do today, right? But you can also separate the concerns better. So you can describe each of these entities as individual attributes. And then you actually connect the data via an independent layer between themselves. So what it allows you to do is basically connect Yang to JSON schema object and so on and so forth. So because we see a lot of things that what people use in the industry is they have a set of data existing in certain systems, and they need to be able to connect them in order to describe certain behavior or certain relationships. And so what I'm trying to explain is that we segregate the what from the how, right? So the relationship is basically how you consume things, whereas the what is actually what the resource is about and what that system is doing. Now, so this is an example of a graph. So typically so my drawings are typically two entities, but what it also allows you to do is basically interact with the system. So from the top, you can actually query all the way down, right? So there is API mechanisms like GraphQL, for example, that we can use in this system out of the box, which basically can allow you to query it. And as a result, you can do a number of things like validation, name definitions, resource allocations, and stuff like that. So it allows you to actually reason and talk or use that data in a very connected way, in a very generalized way.
So you've got 3 person in the queue. You want to keep talking or get feedback?
Yeah,
Question.
let's
Your
get
call.
feedback maybe. Yeah.
So Mahesh, and I think this is thanks first of all for bringing this work both as you said in ops and now into NMOP. NMOP generally tends to be the entry point for work such as this, but its usual destination is somewhere else. And in this particular case, I believe this work belongs in a work group that is not quite formed as yet.
Yeah, so the question is, where does this actual work belong, right? So because at so if you look to there is, in my view, there is something to be standardized. So the mechanism itself is to be standardized. And then, of course, so the NMOP itself is how you consume it and how it's being used. So the question is also, where does it belong in IETF? And so, yeah, I presented here just to share the know-how and the knowledge, and then we'll have to see, okay, where does this land, or does this land in IETF at all?
Fair enough.
Yeah. More questions?
So first of all, I'd like to join you on the draft. You were saying you wanted other authors. That'd be very interesting. But just want to highlight a couple of pieces of work that were done in ONF, TMF before that, actually ONF and ITT. One is what we call the component system pattern, which I think is very much the same sort of shape and purpose as you got. It's a meta schema essentially for a more specific model, but we ended up using hypergraph and hyperedge rather than just graph, because we found that was a more powerful mechanism. It might not yield quite so well to the tools we've got, but it seemed to be more powerful for describing systems themselves and their multi-portedness and so on. So it might be worth, I'd be interested in talking with you on that and pointing out some material on it. So
yeah. So just to be clear, so I personally did the implementation. I know another company who actually built upon the same basis, using a different implementation. So it's actually used at scale in certain things, but I will have to compare.
Because the hypergraph ends up being what's in the network models so we use them in our network models. So we've used that mechanism in the network. So it's interesting. They both got implementations. It's just I don't think there are as many generalized tools around hypergraph.
Okay, we can discuss that.
All right, so we close the queue. Michael, just go. And then,
Hi. I was just wondering, what you described earlier on the graphing and everything else, it looks exactly like RDF. And I'm wondering why you're coming up with your own thing.
Yeah, so first of all, I think, so you have RDF as a modeling language, and what you see sometimes is that what you can see is that you have a very specific, so RDF tries to standardize the whole entity, right? Whereas what we are trying to do is only standardize a very small layers on how you connect that data. And so, for example,
I wouldn't agree with that.
Okay, we can discuss that. But so, for example, like the multi-actor operation stuff is not described in RDF at all. So there is a number of things in this draft that RDF doesn't really talk about at all.
Okay, but that's not a graph schema then.
No, it's the way that, so the set of attributes and operations that you do in order to actually interact with the data in various ways in order to offload some of the capabilities from the client to the server. That's not described in RDF at all.
What I would point out is we have a hackathon that we've just done where we've translated Yang models directly into RDFS schemas. We have instance data, connected them, created them with graph on NMOP on Wednesday. You can hear
Sure. What I'm trying to say is that that's the data, but then the question is, what do you do with the data? So that's what I talk about, the operational side of things. And so what you see is that they typically describe the data concept, but not so much how you interact with it.
So I'm sorry.
That's the second.
That's why to interrupt, but we're way over time.
Yeah.
Thanks a lot. Good discussion. You guys should meet for coffee, I think, or whatever. But please, and the mailing list. Yes.
Yes. Thank you.